Students, this is Mr. Ezra. I'm out today. My kid is sick. I'm really sorry. I know that we don't want this to impact our lessons on probabilities. We haven't done a lot of videos with this class, so one thing that I suggest is as you get to a problem, if you think you might know how to work it out, pause the video, try it, and then start it back up. That's always a good idea to kind of check to see if you're understanding what's going on, is to try to pause it and see if you can work them out on your own. With that said, let's get started. So we left off in class talking about independent events at the end of our last session. So independent events and dependent events really happen when you have more than one probability event in a row. So like the probability of rolling one die and then another die and looking at the outcomes of those two die. When you think about that word and, this happening and then this happening, this is when we're either going to have independent or dependent. It's pretty simple. Independent events, the first probability event has no impact on the second. So you flip a coin and then you roll a die. The coin flip has no impact on the roll of the die. Dependent events, the first probability event does have an influence, does change the second probability event. This is the real common example here is when you're playing cards and I deal you the ace of hearts, the next person can't get that card, right? So the probability of what's left in the deck has changed based on what I've dealt to you. We'll see examples of both of those in the next several problems and kind of look at them separately and together. Our first example today, we have 10 baseball players, 8 soccer players, and 12 basketball players out of 32 people in the room. No one plays more than one sport. Are they mutually exclusive? Well, if none of them play more than one sport, then yes, they are mutually exclusive, because not being mutually exclusive would mean that they could choose more than one sport, that you could get a person that liked basketball and baseball, or played basketball and baseball. In this case, that doesn't happen. So our Venn diagram would have 3 completely separate circles. And if we start filling in things, the baseball players, there are 10 of those. All right, we got that. The soccer players, there's 8 of those. Basketball, there's 12. Well, if we add these numbers together, 10 plus 12 is 22, plus 8 is 30. We haven't accounted for all 32 people. So it seems like there are 2 people in this group who do not play basketball or baseball or soccer. They're just hanging out with their friends who do play sports, and that's okay. But they would be just kind of out here in the space of the Venn diagram that doesn't have any circles, right? This is the space that means none of the circles. Not basketball, not baseball, not soccer. And then we're asked to find some probabilities. And we should be getting pretty good at this by now. Remember that fractions should be reduced, or you can use decimals. And if I make a mistake in the video and you're the first to point it out to me, I will give you some extra points on your next test. I'm going to be trying to do these in my head, so it's very likely that I'll make a mistake. Okay, so what's the probability that someone plays baseball? Well, there are 10 people out of the 32 that play baseball, right? So if you reduce that fraction, that would be 5/16. I would be okay with the decimal version of that. I just don't know what it is. What's the probability that someone plays soccer? Well, there are 8 soccer players out of the 32. So if we reduce this, let's see, 8 goes into 32 4 times, so that would be 1/4. I do know that decimal would be 0.25. What's the probability that someone plays basketball? Now we've got 12 out of the 32. Okay. Both 12 and 32 divide by 4, which leaves us with 3 out of, let's see, 8. 3/8 would be the fraction. And again, if you get a decimal version, that's fine, no problem. What is the probability that one does not play one of the 3 sports? Well, we said that there were 2 people who do not play one of the 3 sports. So that would be 2 out of 32, or 1 out of 16. What's the probability that they play baseball and soccer? Well, let's talk about and really quickly, because I don't know if we've done a good job of this. In order for and to be true, they would have to play both baseball and soccer. How many people play both baseball and soccer? Well, hopefully you are seeing that there are 0 that play baseball and soccer. So the probability that we would get someone who does both in this case is 0. But if we say baseball or soccer, in this case they could play baseball and it would be okay. Or they can play soccer and it would be okay. Or they can play both. So we'll take the baseball players, there's 10 of those, and the soccer players, there's 8 of those, and we'll put those together to get 18 out of the 32. If we reduce this, we get down to 9/16, I believe. All right, soccer or basketball. Remember, or, it's okay to play soccer. It's okay to play basketball. So we'll put those together to get 20/32. And 20/32, I believe, is 4 over, oh, sorry, that's 5/8. 5/8. All right, plays either soccer, basketball, or baseball. So that's all 3 of the circles together. Any of the sports would be fine for this. That's going to be 30 out of the 32, which is 15/16 as a reduced fraction. I don't know what the decimals are, but decimals would certainly be okay here. All right, next example. Remember, pause the video, try it out, see how you do, and then start it up, see if you get it right. All right, this time we do not have a mutually exclusive event or a mutually exclusive situation. There is overlap. There are people who play multiple sports, okay? So I like to start with the group that is, or the part that represents all 3. So one person plays all 3 sports. And then from there, I'm going to try to build out. 5 players play basketball and baseball only, okay? So basketball and baseball only means that they are in this spot right here, because only means that they don't play soccer, right? It's only basketball, only baseball, so we've handled this part. 2 play soccer and basketball only, okay? Soccer and basketball only is the overlap of that, and they don't play all 3 here, so that's going to be 2 people right here who play soccer or basketball only. That's taken care of. 3 of the players play baseball and soccer only, so I guess you can kind of catch the drift here that we're going to find the overlap of soccer and baseball, and not the part like this. This is all 3. We're not including that because it says only, so we'll put 3 here. And then it says there are 10 baseball, 8 soccer, and 12 basketball players out of the 32 people in the room. So here we have to think about it a little bit. We have 10, let's start with the baseball players, 10 baseball players, okay? Of those baseball players, we've already accounted for, let's see, 9 of them. So there's only 1 baseball player left over that is not playing some other sport. Of the 8 soccer players, we've already accounted for 3, 4, 6 of them, so that leaves 2 out here that are not playing any other sport. And of the 12 basketball players, we have accounted for 5, 6, 8 of them. So that leaves 4 basketball players that are only playing basketball. Now, have we accounted for everyone? Well, we know that there's a total of 32 people in the room. How many have we accounted for? So let's add these up. Let's see, 1 plus 3 is 4, 6, 8, 9, 14, 18. Only 18 of the 32. So there's a lot of people in the room that aren't playing any of this, that aren't playing any of the sports. Okay, so we have 32. We just said that 18 of the players are playing sports. So what does that leave us? Let's see, borrow the 1, 4, minus 14. 14 people out here in La La Land that are not playing any sports. It's okay not to play sports, but we just want to make sure we think about those players. All right. So back to our questions. What's the probability that someone plays Baseball. Well, playing baseball would include people who play any of the other sports because it doesn't say just baseball or baseball only. It just says play baseball. So that'd be the 1 plus the 3, 4, 5, 10, which we already knew that there were 10. So that's going to be 10 out of the 32, which is going to reduce to 5 out of 16. Now, if they play only baseball, they can't play any other sport. So we're going to say 1 out of 32, and that does not reduce. All right, soccer would include the 2 plus the 2, 4, 5, 8, right? We knew there were 8 already up here, so 8 out of the 32. 8 out of 32 reduces to 1/4. Plays only basketball. Well, only basketball means no other sport, just basketball. That's this area over here. There are 4 out of the 32, which is 1/8. Does not play one of the 3 sports. Well, there are actually a lot of people this time that don't play one of the 3 sports. 14 out of the 32 are out here and don't play any sports. That's going to reduce to 7/16. All right, played baseball and soccer, but not basketball. Baseball and soccer, but not basketball. So that's this 3 right here. That 3 right there. So 3 out of 32 does not reduce. All right, plays baseball or soccer, but not basketball. Now, remember the difference between and or. And means it has to be both baseball and soccer. So that's why we were looking at the overlap right here. Baseball or soccer is all of the baseball circle and all of the soccer circle, but in this case, not basketball. So we're going to take out any of the basketball circle. So for or, it can be one, the other, or both. In this case, not basketball. So we've got to make sure that we're not counting those. So that's 1 plus 3 is 4, plus 2 is 6. So 6 out of the 32, which reduces to 3/16. Right, plays soccer or basketball. Right, soccer or basketball. In this case, that would be all of soccer and all of basketball. So we're really looking at everything that's shaded there. So that's, let's see, that's 2 plus 2 is 4, 7, 8, 13, 17. So I'm counting 17 there. 17 out of the 32 does not reduce. Okay. Finally, either soccer, basketball, or baseball. Soccer is good, basketball is good, baseball is good. So any of the 3 sports altogether is what we're talking about. So if we add those up, which we've already done, we get 18. So it's 18 out of the 32, which reduces to 9/16. So you can see once you build your Venn diagram, you got to think about the overlap and when you're filling it in, and you got to think about the fact that some people aren't playing any, right? And then and means both, or is one, the other, or both. Okay. All right. A box contains 3 glazed donuts, 4 jelly donuts, 5 chocolate donuts, and 1 glazed chocolate donut. So what I'm seeing here is a Venn diagram where 2 of the circles share 1 donut, 1 glazed chocolate donut. Okay. Now, jelly doesn't have any overlap. It's out in space here. But the chocolate and the glaze do. Of the 5 chocolate donuts, 1 of them is also glazed. So 5 minus 1 is 4. Of the 3 glazed donuts, 1 of them is also chocolate. So 3 minus 1 is 2. Because it says that the box contains these donuts and these donuts only, I'm assuming that there are no donuts in the box that aren't in this group of donuts. So the total number of donuts is 2 plus 1 is 3 plus 4, 7 plus 4, 11. So I've got 11 total donuts in the box, which is kind of strange. Should be a dozen, shouldn't it? Well, we're just following what it says here. So what's the probability that it is glazed? Well, glazed would include the 2 and the 1 that's glazed and chocolate. So that's going to be 3 out of 11. The probability of chocolate would be the 4 just chocolate plus the 1 that's also glazed. So that would be 5 out of 11. Now, chocolate or glazed is one or the other or both. So that's this whole area in here that we're talking about. 2 plus 1 plus 4 is 7. So we're looking at 7 out of 11. All right, glazed or jelly. Glazed is that whole guy, jelly's that. It says or, so we can count both. So that's 2 plus 1 is 3 plus 4 is 7. So also 7 out of 11. All right, jelly. There's 4 jelly out of the 11. That one's pretty easy. Chocolate and glazed. It has to be both. It has to be the overlap, both chocolate and glazed. There's only one in the 11 donuts that meets those qualifications. And then jelly or chocolate, or can be jelly or chocolate. They both count. So 4 plus 4 is 8, plus 1 is 9 out of the 11. Hope you're kind of making sense of this, and it's working for you. Let's look at another example. Right. A month of the year is selected at random. What's the probability that it is January or December? Okay, well, there are 12 months. One is January, one is December. That's 2 out of the 12, which reduces to 1/6. What's the probability that is January or February? So they're both good. Or it begins with the letter M. Well, there's March and May. So that's 1, 2, 3, 4 out of the 12. That reduces to 1/3. 1/3 of them are either January or February or start with the letter M. Okay, it is one of the first 3 months. One of the first 3 months. Or it begins with the letter J. Now, we're not going to count this January J twice. We've already underlined it, so we're just going to add on the other J's, June and July. And that gives us 5 out of the 12, which does not reduce. And finally, find the probability that it begins with the letter M. So in this one, we've got M for March and May. And it is in the last half of the year. Well, since there's 12 months in the year, we're looking at the last 6 months. So coming from the end, we've got 1, 2, 3, 4, 5, 6. Well, and has to be true for both. It has to be both beginning with the letter M and also in the last half of the year. Unfortunately, none of these, or there is no overlap here. There's not a month that meets both of these qualifications, so the probability is going to be 0. And I just noticed that the name Jason is in the initials here. That's kind of neat. All right, a single card is drawn from an ordinary deck. Just one card. What's the probability that it is a king or a club? All right, well, if we think about the deck of cards, 1/4 of them are clubs, right? There are 13 clubs. And in those 13 clubs, one of them is a king. Outside of those 13 clubs, there are 3 kings that are not clubs. We've already counted one of the kings, plus 3 more. That makes 16 out of the 52 cards. Okay. So that is going to be, let's see, 4 out of 13, I think. All right, B, a diamond or a 3. All right, well, there are 13 diamonds, right? And there is a 3 of diamonds. And outside of the 3 of diamonds, there are 3 more cards that are also 3s that are not diamonds, right? So I'm just thinking, I'm making sure I don't include a card 2 times, right? I'm subtracting out the overlap. In the formula, this would be the probability of a diamond plus the probability of 3 minus the overlap. So let's look at this both ways. The way I'm doing it is just saying, well, there's 13 plus 3. Well, that's 16 out of the 52, right? Boom, done. I'm just thinking about it. I'm not using the formula. If I use the formula, I would say the probability of a diamond is 13 out of 52. The probability of a 3 is 4 out of 52. The overlap is 1 3 of diamonds, 1 out of 52. I subtract it out. I can't count it twice, and I end up with the same answer. So same thing for part A. I mean, you can use the formula, add the 2 probabilities, subtract the overlap. That'll get you there. Or you can just think about it, right? Either way is fine. Let's try the formula with a jack or a red card. Okay, what is the probability of a jack? There are 4 jacks in the 52 cards. What's the probability of a red card? Well, half of the cards are red. So that's 26 out of 52 cards. We have to now subtract out the overlap. How many cards in the deck are both jacks and red? Well, there is a jack of diamonds and there is a jack of hearts. So there's 2 that we counted as a jack, and we also counted as a red card, so we need to subtract them out. So that's going to be, let's see, 30 minus 2 is 28 over 52. 28 over 52 reduces to 7 over 13. D, a number card and a diamond. Right now, and is not like or. And has to be a number card that is also a diamond. Okay, so let's do a little thinking. Number cards in my book do not include aces. So we've got 2, 3, 4, 5, 6, 7, 8, 9, and 10. After 10, you get Jack, Queen, King. They're not numbers, right? Of the diamonds, there is 1 2 of diamonds, 1 3 of diamonds, 1 4 of diamonds, and so forth. So if we count these up, there's 1 2 3 4 5 6 7 8 9 cards in the deck that are both number cards and diamonds out of the 52. I do not believe that reduces. Finally, we get a face card and a black card. So remember, and means it has to be both face card and black card. All right, so face cards would include Jack, Queen, and King, right? So let's do some thinking really quickly. Because half the cards are black, this includes spades and clubs. There's 2 jacks, 2 queens, and 2 kings. So altogether, 2 black queens and 2 black kings. 2 suits that are black. So we've got altogether 6 cards in this deck that are both face cards and black cards. So that's 6 out of 52, which reduces to, let's see, 3 out of 26. Again, if I had my calculator with me and I was in class, I'd probably make all of these into decimals, but I don't have my calculator with me. I'm doing this from home. Just going to leave them as fractions, but I would love to see them as decimals on any practice that you do. Okay, so we are getting to some practice problems where we're not using Venn diagrams, we're not thinking about the sample space. Instead, we're going to use the two-way table to show the sample space. We're getting close to the end of the video. I know there's a lot of examples today, but I really want to get through all of these, and then we can practice in class all day Wednesday and prepare for our test on Friday. In a hospital unit, there are 8 nurses and 5 physicians. So when I got my two-way table, nurses and physicians in my two-way table are on the left here. And I'm going to go all the way to the right because I know that there are a total of 8 nurses and 5 physicians. 7 nurses are female. So of the 8 nurses, 7 are female. That leaves only 1 nurse that is male. If 7 are female, 7 of the 8, that leaves 1 of the 8 to be male. 3 of the physicians are female. So of the 5 physicians, 3 of them are female, which leaves of the 5, 2 to be male. So by looking at this, we're filling in our table. Now we say 1 plus 2 gives us 3 males. 7 plus 3 gives us 10 females. And altogether, my total for the row of males plus female, 13, plus my total column for nurses plus physicians, they have to equal the same thing, which is 13. So, got my two-way table now. One of these people is chosen at random. What's the probability that the person chosen is either a nurse or a male? Now, when we do this, remember, or is pretty powerful. All of the nurses count. All of the nurses count. Or male, all the males count. Now, I can do this 2 ways. I can use that formula that we learned where we subtract out the overlap. What's going to happen is when I use the nurses and then I find the probability with the males, I'm going to count the male nurse 1 time, or 1 too many times. I'm going to count them twice. So I'm going to subtract out the overlap. So first, probability of nurse is 8 out of 13. Plus, probability of male is going to be 3 out of 13. But I have counted the male nurse too many times. I've got to subtract out that overlap. I cannot count this person, this one part of the problem, this one male nurse. I can't count him twice. So I subtract him out. 1 out of 13. That's a 13, by the way. Which gives me, let's see, 8 plus 3 is 11, minus 1 is 10 out of 13. Now, could we have done this without using the formula? Well, certainly. We could have just looked at all of the cells inside the table that make up either male or nurse and added them together. 7 plus 1 is 8, plus 2 is 10. Gets us to the same place without a formula. So you don't have to memorize the formula. But it isn't hard. It's difficult. You can totally do it. All right, so I know that we didn't get through all of the examples today, but we got through most of them. We'll finish them up on Wednesday and start practicing, getting ready for a test on Friday. I hope that everything we've talked about has made sense. You don't have any formal homework at this point.